The question is, could you do an example on finding the projection of a force in a certain direction by using the dot product? This is the problem that I have selected here. There is a cable going from point O to point A, and the tension in the cable is 20 kilonewton. These 3 points, points O, A, and B, are simply points in the space, and their coordinates are given here. Here are the questions. We want to find the angle theta, which is the angle between the line OA and OB. We want to find the component of the tension along the direction OB, and we also want to find the component of the tension perpendicular to OB. From the definition of the dot product, we know cosine theta equals A dot B over A times B, where little a is the magnitude of A and little b is the magnitude of the vector B, right? This is a three-dimensional problem, and therefore this route of using the dot product is the best way to handle this problem. So first, for each of the two vectors, I'm going to find its component form and its magnitude. Here are the calculations for finding the component form for vector A. You remember this approach from an earlier video, right? We have the coordinates over here, so substitute numbers, and this is what I come up with for the vector A. Here is the magnitude of A. I get 5.41 meters for little a. Now we repeat this for vector B. Here are the details, and this is the vector I get for B, and it turns out that the magnitude of B is the same as the magnitude of A. Here is a summary of the results from the previous slide. So let's go ahead and find the dot product between A and B. Since we have the component form for the two vectors, let's use this expression right here. You recall this from one of the previous videos, right? So we recognize that this is AX, this is AY, this is AZ, this is BX, BY is 1, and BZ is 3.5, right? Substituting the numbers, we get a value of minus 12.75 for A dot B. If you are keeping track of units, the unit of A dot B is going to be meter squared. A is in meters, B is in meters, and therefore A dot B is in meter squared. Now we can easily find the angle theta. So here are my calculations, and I get a value of 115.8 degrees for theta. Now let's go ahead and answer the other two questions. First, let me make a 2D sketch like this, which shows the angle in a more clear manner. Here is the line OB, and here is the line of action of the tension in the cable, and the angle between the two is 115.8 degrees. Now it's easy to see that the projection of T onto OB is this much, right? And the projection of T in a direction perpendicular to OB is this much. If I were to find the component of T by referring to this picture, I would say the component of T along OB is simply T cosine theta, right? So if we go through that route, we get a value of minus 8.71 kilonewton. The minus sign, of course, is consistent with what we are seeing here. In other words, the component of T is not along OB, actually in the negative direction of OB. We have a right triangle here, and therefore T squared must be equal to this squared plus 8.71 squared, and therefore this squared is T squared minus 8.71 squared. In other words, this length is simply square root of T squared minus 8.71 squared, which is 18 kilonewton. In other words, the component of the tension T in a direction perpendicular to OB is simply 18 kilonewton. So we answered all of the questions.